In this section, we will be looking at logarithmic equations. We're going to start by solving logarithmic equations that have one logarithm. And if a logarithmic equation only has one log, the easiest method is to convert it to exponential form. So we have two examples we're going to take a look at. First up, we have log base 10 of 4z is equal to 2. I'm going to put in the parentheses just so I can clearly see what my argument is at 4z. And now I'm going to switch it to exponential form. So I will have 10 raised to the 2 power, so 10 squared, is equal to my argument, 4z. Well, I know what 10 squared is. That's 100. So I have 100 is equal to 4z. If I divide both sides by 4, I get that z is equal to 25. That's all there is to it. Next up, we're looking at 2 times the natural log of 3x is equal to 2. Well, I do have just one logarithm, so I want to put it in exponential form, but I can't do that until the logarithm is by itself. So I need to get this first 2 out of here. Since that 2 is multiplied by the natural log, I can get rid of it by doing the opposite of multiplication, which is division. And I'll have the natural log of 3x is equal to 2 divided by 2 is 1. When I go to put this in exponential form, I need to know what base I'm working with. But I don't see a base. You have to remember that the natural log has a base of e, even though we don't see it. So now I can put it in exponential form, giving me e to the first power is equal to 3x. But e to the first power is just e. So to solve for x, I need to divide both sides by 3. I get e over 3 is equal to x. You can leave your answer just like that. No problems. Life is good. If you are the type of person who really, really likes to have a decimal answer because it just makes you happy, you can type it into your calculator. And if you have one of the calculators where when you use the e button, it gives you e raised to a power, you can just use a power of 1. So e to the first divided by 3, and there's your decimal answer. Just like we have seen in previous problems, when we solve for a variable, then we can check our answer by plugging it back in. This is going to be a really good idea when we are solving logarithmic equations, because as we saw a couple sections ago, the domain of logarithms is not all real numbers. There are certain numbers we can't plug into logarithms. Right? So I'm going to check these two answers to make sure they're right and make sure I'm not making any mistakes. So over here we have log base 10, that's just a common log, of 4 times my z value equals 2. So I know that one's right. Over here, plugging into the original, I have 2 times the natural log of 3 times, oh, nope, I actually have a regular old e button. E divided by 3 is equal to 2. So I know that both of these ones turned out okay. So if you're dealing with one logarithm, your best bet is to put it in exponential form. But you can't put it in exponential form until your logarithm is by itself. So what if we have 2 logarithms? If a logarithmic equation has 2 logs, we can use what's called the one-to-one property. It says if log base a of x is equal to log base a of y, then x must be equal to y. So if the log of x is equal to the log y, x has to be equal to y. Hopefully that makes sense. As a note, the base must be the same on both sides, and it just has to be one log on both sides. That's going to be important. So here we have 2 examples. First up, we have log base 2 of 2x minus 3 is equal to log base 2 of x plus 4. I'm seeing a log base 2 on both sides, so that means that the insides, the arguments, have to be equal. 2x minus 3 has to be equal to x plus 4. That's an equation I know how to solve. I can subtract the x over, giving me x minus 3 equals 4. Add the 3 over, x equals 7. I can check my answer by plugging it back in. What I'm most worried about is getting 0 or a negative in an argument, because we know that's bad. So if I plug in 7 over here, 2 times 7 is 14. 14 minus 3 is 11. That's okay. Over here, 7 plus 4 is 11. So I have log base 2 of 11 on both sides. So that's okay. Next up, I'm looking at the natural log of 3x minus 5 is equal to the natural log of 2x plus 1. Just like the last time, I can take the insides, the arguments, 3x minus 5, and set it equal. Is equal to 2x plus 1. I can subtract the 2x over, giving me x minus 5 is equal to 1. Add the 5 over, and I get x equals 6. Plug it in and make sure we get the same thing on both sides. 3 times 6 is 18. 18 minus 5 is 13. I have the natural log of 13. Over here, I have 2 times 6 is 12. 12 plus 1 is 13. I have the natural log of 13. The natural log of 13 is indeed equal to the natural log of 13. Cool. Well, there has to be a case where it gets more complicated. So we've seen one logarithm on both sides. We've seen, one logarithm in our problem. We've seen 2 logarithms in our problem. Now we have 3 logarithms, and we have to figure out what to do with them. This is where the properties of logarithms are going to help us out. So we want to solve log base 10 of x plus 6 minus log base 10 of x is equal to log base 10 of x plus 2. What I'm noticing is I have 2 logarithms of the same base that are subtracted. I can use my logarithmic properties to combine these into one, and because they're subtracted, that will turn into division. So I have log base 10 of x plus 6 divided by x is equal to log base 10 of x plus 2. Now I have just one logarithm on each side of the equation, and I can solve this like the last one. I can set the insides, the arguments, equal to each other. So I have x plus 6 over x is equal to x plus 2. I need to figure out how to solve that. There are 2 good ways about going about this, and they really amount to the same thing. I could multiply both sides of my equation by x, or I could think of this as x plus 2 over 1 and cross multiply. I'll get to the same place. 1 times x plus 6 is x plus 6, and then that'll be equal to x times x plus 2. So I cross multiplied. If I multiplied both sides of the equation by x, I would have gotten to this exact same place. On the right-hand side, I can distribute my x, so I'll have x plus 6 is equal to x squared plus 2x. This is now a quadratic equation. I can tell because there's an x squared. And to solve quadratic equations, it's easiest if I put all the terms on one side. So I'm going to move everything to the right so my x squared stays positive. So I'm going to subtract x over and subtract 6 over. That'll leave me with 0 equals x squared plus x minus 6. Now that's something that factors. So I'll have 0 is equal to x plus 3, x minus 2. And that gives me x is equal to a negative 3 and a positive 2. All right, but we have a problem. The argument of all of my logarithms has to be positive. Right here, I'm looking at log base 10 of x. If I plug in x equals negative 3, I'm going to get an error. I have to throw that one out. And if you're worried, plug it into your calculator. If I do log base 10, that's my common log, of x plus 6, negative 3 plus 6, minus log of negative 3, I get an error, a non-real answer. So I know that one doesn't work. Let's try it with 2. Log of 2 plus 6 minus log of 2. And I want that to be equal to the log of 2 plus 2. And they are equal. So I know x equals 2 is a good answer. So with our logarithmic equations, make sure to check your answer because not all of them are going to work every single time. We're going to try one more where we're using these properties of logarithms. We have log base 2 of x plus log base 2 of x plus 3 is equal to log base 2 of x plus 8. So first up, I see that I have two logarithmic expressions added together with the same base. So I can combine them with multiplication. I'll have log base 2 of x times x plus 3 is equal to log base 2 of x plus 8. Since I have log base 2 on both sides, I can just look at the arguments. They must be equal. So x times x plus 3 is equal to x plus 8. I can distribute through on the left-hand side. And I'll have x squared plus 3x is equal to x plus 8. Just like the last one, I have a quadratic equation, so I want to move everything to one side. I'll move everything to the left, so my x squared stays positive. And I'll have x squared, subtract the x, so plus 2x, subtract the 8, minus 8 is equal to 0. That factors into x plus 4, x minus 2 is equal to 0, giving me x equals a negative 4, a positive 2. But remember, I cannot have a negative argument. I can't have a 0 argument. So if I plug in either of these x values and I get something other than a positive number for my argument, I have to toss it out. Plugging in negative 4, I get a negative argument. I get another negative argument. Negative 4's got to go. If I plug in 2, things look good. But let's check it just to be sure. So I'm looking at log base 2 of 2 plus log base 2 of 2 plus 3 is 5 is hopefully equal to log base 2 of 2 plus 8 is 10. And we know by our logarithm rules that because these two are added together, I can multiply their arguments. Log base 2 of 10 equals log base 2 of 10. We're good to go.